Okay. So today we're going to learn about integration by parts. So we've seen a lot in Advanced and Extension 1 of integration. We've learned how to take the antiderivative, we've learned how to take the integral of different functions, and we've learned some applications like finding the area under the curve. What we haven't seen, however, is we know that, okay, the integral of x squared dx, we know is going to be x cubed on 3 plus c. So we're adding 1 to the power, dividing by 3. Nice and easy. But, what if I've got the integral, say, of e to the x sine x dx? And I'm like, oh, okay. Well, I know how to integrate e to the x. The integral of e to the x is just e to the x plus c. And I know that the integral of sine of x dx is minus cos of x plus c. But I'm like, okay, what happens if I've got the product of functions? Like, what if I've got what I just wrote down there, e to the x sine x? It becomes a bit tricky. And that's where we're going to learn the fun little process of integration by parts. So we know that the product rule of differentiation tells us this. D by dx of u times v. Well, hopefully we should all know that it tells us that it's v times du dx plus dv on dx times u. Right. Well, we're after the integral of u times v. So we're thinking, okay, what if I integrate both sides? So integrate, integrate, integrate. So if we integrated d by dx, we're just left with u times by v. And if we integrate this, where we're looking at the integral of v du on dx plus the integral of u dv on dx times dx. Okay. Now again, we're after the integration of these two different functions. So if I have a go at rearranging this, so I've got u times v is equal to the integral of v times du dx times x plus the integral of u times dv to x dx. Right, let's have a go at rearranging this. I'm going to rearrange it for this thing at the end. So the integral of u dv dx is equal to u times v minus the integral of v du on dx. Okay. So that is the long form of the integration by parts formula. But here we've got dv dx. Now, in shorthand, we might just say that's the integral of u. Now, dv dx is v dash. So the integral of uv dash is equal to u times v minus the integral of v. Now, du dx is u dash dx. And that is our formula there. So my integration by parts formula states that u v dash is equal to u times v minus the integral of vu dash. Okay, that's our formula there. So the integration by parts formula is extremely useful because it allows us to find the integration or the integral of the product of two functions. In fact, it actually does work for any integral, and we can just let the second thing equal to 1. So if we want to, for example, find the integral of x ln x dx, Now, the advantage of learning integration by parts is A, it allows us to take the integral of product functions. But in extension 1, often they will get you to differentiate a function, find its differentiation, and then in part 2, you'll be asked to use that information to find the integral. Now, if you know how to do differentiation by parts, and part 2 says hence or otherwise integrate, you can use integration by parts to integrate, or at least confirm your answer. So the integral of x ln x. We're going to write this, and I like to call integration by parts the v method. So we're going to say u dash, v dash, and v. Okay. Now the information we've got is u and v dash. Now we've got to decide what do we want u to be and what do we want v dash to be. Now I know that it's very, very easy to integrate and differentiate x, but it's harder to integrate ln x. So we're going to make u ln x, and that would make u dash 1 on x. Now we're going to make v dash our x, because we can easily integrate this, and we're going to get x squared on 2. So from here to here, we're differentiating, and from here to here, we're integrating. Then I'm going to draw my little tick. I'm going to go like this. My answer is ln x times by x squared on 2. And then I'm going to draw the rest of my tick minus those two things we just connected, multiplied, but we've got our integral, minus the integral of x squared on 2 times 1 on x dx. So that's equal to ln x times x squared on 2 minus, that will cancel and that will cancel. So I've got minus the integral of x on 2 dx. Taking out the half, we've got ln of x times x squared on 2 minus the half integral of x dx, which is equal to ln of x squared on 2 minus 1 on 2 times by the integral of x is x squared on 2 plus c. So my final answer is going to be x squared ln of x on 2 minus x squared on 4 plus c. Have you ever had more fun? I haven't. Okay, question number 2, we're going to find the integral of e to the x sine x dx. Again, we're going to use integration by parts here because we cannot integrate two functions such as these multiplied by one another. We're going to use our tick method, so we're going to say u dash, v dash, and v. And we're going to think, okay, what do I want u to be? What do I want v dash to be? Now, in this case, it doesn't really matter because e to the x and sine x are both very easy to integrate and differentiate. I might let u equal to sine of x because if I let v dash equal to sine of x and I integrate sine of x, I get minus cos of x, and I don't like minuses. Differentiate sine of x, we get cos of x. Now we're going to set our v dash to equal e to the x. We integrate e to the x, we still get e to the x. Again, we're usually always making v dash the thing that's easiest to integrate. So we're going to say, okay, this is equal to, using our tick method, e to the x sine of x minus the integral, connecting our tick, of e to the x cos of x. Okay. This is where it gets really, really fun because we need to integrate by parts a second time. So we're going to have a go at integrating by parts this because we've got the product of two functions again. So we're going to say this is e to the x sine of x, and we're going to integrate by parts again, minus, big brackets, u equals e to the x, u dash, we've got v dash equals cos of x, and v is equal to. So again, actually we might swap these around because it's a bit easier to differentiate cos of x. Differentiate cos of x, we get minus sine of x. Putting e to the x here, e to the x is nice and easy to integrate, we still get e to the x. So we're minusing, doing our tick method, e to the x cos of x minus the integral of e to the x times minus sine of x. I might fix that, it's a bit messy. Okay, and close that bracket. So here we've got e to the x sine of x minus e to the x cos of x. And here we've got a triple negative here. It's going to be minus the integral, so this negative times that negative times that negative, minus the integral of e to the x sine of x dx. Okay, and we're thinking, I've got to integrate by parts again. But we don't actually have to, because this is what our question was. So the original question was to find the integral of e to the x sine of x. And it's equal to, we're told that it's equal to e to the x sine of x minus e to the x cos of x minus the integral of e to the x sine of x dx. So if I plus this over to here, I would get 2 times by the integral of e to the x sine of x equals e to the x sine of x minus e to the x cosine of x. And to find my integral, I simply divide by 2. I love these types of ones. E to the x sine of x is equal to 1/2 e to the x sine of x minus e to the x cos of x. And that type of skill is going to be a lot more useful later and will make a lot more sense when we do recurrence relationships and integration. Okay, a couple more examples. So example number 3, we're going to find the integral of x e to the 2x, and we're going to use integration by parts. So again, we're going to say u equals u dash equals, why does that keep doing that? U dash equals, v dash equals, and v equals. Now, whenever we have x, we're always going to make that, or I'm pretty sure always, we're always going to make x equal to u, because if you then find u dash, you're going to get 1, which is going to make your life a lot easier. So that would make sure we're making v dash equal to the other function, e to the 2x, and that would obviously integrating that, making that 1/2 e to the 2x. So following our tick method, it's going to equal x times 1/2 e to the 2x minus the integral of 1 times 1 on 2 e to the 2x. So we've got dx, x on 2 e to the 2x minus 1/2 times the integral of e to the 2x dx. Now we should all know that the integral of 2x is 1/2 e to the 2x. So we've got x e to the 2x on 2 minus 1/2 times 1/2 e to the 2x plus c. So hopefully we should know those halves are going to combine. We're going to have x e to the 2x on 2 minus 1/4 e to the 2x plus c. I bet you I forgot the plus c in the other example. I did. Plus c. Okay, number 4, last one. Let's find the integral of ln x. Okay. These ones are really cute. And they love to do stuff like this in extension 1. They'll get you to find a differentiation, and then they'll do the integration. And knowing this skill is very good to have for extension 1 and advanced. At least it's got something in the back of your mind. I can confirm my answer through doing integration by parts. Now the problem with this question is we've only got one function, and we don't know how to integrate ln x. I can differentiate it, I get 1 on x, but I can't integrate it. So I'm going to say, okay, well, this is 1 times by ln of x. So my other function is actually 1. So I've got u dash, v dash, and v. Okay, now we have to set u to be ln of x, because if we set v dash to be ln of x, that kind of just defeats the whole point of the question, because we don't know how to integrate ln of x, so we've got to differentiate it and get 1 on x. V dash should be 1, which would make v x, the integral of x is 1 is x. So using our tick method, we're going to have ln of x times x minus the integral of x times 1 on x dx. Now x times 1 on x is 1, so we've got ln of x times x minus the integral of 1 dx, which is ln of x times x minus x plus c. Okay, hope that makes sense. That's integration by parts for you.